having us this morning in your classroom. I've heard that you have some really good thinking going on in your math, and I just kind of saw a little bit of that already. I want to introduce myself. My name is Mrs. Goerig, and what I'm going to do today with you is we're going to do a number string, okay? I'm Brittany Goerig from Hand2mind. I was the lead author on Daily Math Fluency. I was a classroom teacher for 17 years. Of those 17 years, I was in elementary for 16, and then I decided to become a middle school 7th grade math teacher. I really wanted change and challenge in my life, and I definitely got both. One of the reasons why I went to 7th grade was that I wanted to go see what the middle school teachers kept telling the elementary teachers, which was, they don't know this, they don't know that. And one of the biggest things was they kept telling me they didn't know their basic multiplication facts. So I went to 7th grade and I found out they didn't know their multiplication facts. But I will tell you this, we are doing a lot of things right in elementary, but the problem is that sometimes we just don't know the right vocabulary that they're using, and they're not able to connect what we're teaching to what we're teaching in elementary. As a classroom teacher, I began by teaching the exact same way that I was taught, and that was through memorization. Then I had some amazing opportunities. Those opportunities led me to figure out that kids could actually figure things out on their own if they were provided with the correct tools. One of those tools I learned about was number strings. I tried number strings out in my 2nd grade classroom and figured out that kids were really able to construct strategies. I didn't have to stand up in front of them and tell them how to do something. They could actually figure it out. I saw the benefit in these, which led me to working on the project with Hand2mind. I'm so excited that you have Daily Math Fluency in your classroom and are able to see how your students are going to be able to construct these strategies by using the number strings in Math Talks. One component in Daily Math Fluency are number strings. A number string is a series of related problems. On the number string cards that are provided in Daily Math Fluency, you will find the series of related problems on the left-hand side. The teacher would ask, what is 84 plus 20? And write that up on the board. What is 36 plus 30? So what is 36 plus 30? So if you know what 36 plus 30 is, put your thumb right here. After the teacher has written the problem on the board, the students will be mentally solving this problem. The teacher will be walking around, or the students will give them some type of the teacher a signal that will allow them to know if they have the answer or not. One signal that you could use is just a thumbs up. So a lot of students like to put their thumb right here, and so that everyone else can't see it. After the teacher notices that most students have an answer, they can call on that student to share how they solved 84 plus 20. What's 36 plus 30? 66. Did anyone get something different? Did you get some? No. Okay. So, will you tell us, how did you do that? How'd you figure that out?
Because I saw the 6, and on the other side there was a 0, and 6 plus 0 is 6, and 30 plus 30 is 60, and 60 plus 6 is 66.
During a number string, the teacher models student thinking. In Daily Math Fluency, there are a variety of manipulatives and models that are used. The manipulative or model is indicated on the number string card. On the right-hand side, you will find that model, and you will find an example of a student's explanation and what that might look like. So I think I heard you say that you thought about the 36 as 30 and 6, and then you had this 30 right here. And so you already knew that 30 and 30 was what?
60.
60. And then you just had the 6 right here. So 60 and 6 is 66. Nice. Did anybody use their tens to think about this? Did anyone use tens to think about this? Yes. How'd you do it?
I used my tens, and I know 30 plus 30 equals 60.
Mm-hmm.
And there's 0, so you put the 6 with the 0.
Yeah, so kind of very similar to what she said, right? So you use those tens of 30 and 30. Nice. Anyone do something different? Number strings are focused towards a particular strategy, a big idea in mathematics, or a model. You will know what your number string is focused towards based on the title of the card. On the number string card, you will find a series of related problems that have been written purposely in an order that will systematically nudge students towards an efficient strategy. While conducting a number string, a teacher facilitates who shares by asking questions and drawing out the relationships from the student's explanation. This gives teachers the opportunity to help the students construct the strategy that the number string was written for. How about this one? What about 36 plus 38? Can you tell me what's 36 plus 38? What'd you say? 74. Remember, let's talk really loud so we can hear, okay? So 74. Did anyone get something different? Did you get something different? Okay, 74. Okay, how did you do that?
I knew 8 plus 6 makes 10, so I added 2 more, and then I had 4 more ones, and then I added 3 plus 4 makes 7, and 8 to other 4 is 74.
So I think I hear you kind of thinking about your place value. So you thought about your 6 and the 8, and you knew that was 14. And then you had your ones, and then you traded and did your tens. So then you had the 4. Nice way of thinking. Did anyone think of it a different way?
First, I thought 30 plus 30 equals 60. 8 plus 6, and want it equal like a number less than 10.
Mm-hmm.
So then, I needed 2 more to add it to 8. So then I subtracted 6 from the 8,
Mm-hmm.
and then I ended up with 74 because the extra 10 went.
Because then the extra 10 went there. So it's kind of what I think I hear you saying is you thought about that again, kind of like we thought about these two numbers as 30 and 6 and 30 and 8. Because you said you knew 30 and 30 was what was that again? 60. And then you talked about how you knew 6 plus 8 was 14. Because you knew you could take 2 from this to make that a 10. And then you had 4 more left over. Or you still had your, you still had your 4 more left over. So that would make your 14. Is that right? Okay. So you know 6 plus 8 is 14. And so 60 plus 14 is 74. So splitting those. So let me ask you a question. Did anybody use this problem to help you? Is there anyone in here who used 36 plus 30 to help you know that 36 plus 38 is 74? Yes, sir.
Like the top one, the answer is 66, and then.
So I'm going to stop you there. So I'm going to model what you said, just right underneath it. So you know 36 and 30 is 66. Now what?
And then on the bottom it's 36 plus 38, so it's just 8 more.
So it's just 8 more. So if I already know 36 and 30 is 66, now I can just put 8 more. So how do you put 8 more with 66?
Like you first take 4 out of 8, and then it's 4 and 4, and then
So 66 and 4, what does that get you?
70.
70,
And
which
then
is a nice number. And then you just have how much more?
4 more.
You just have 4 more left. And that's what?
That's 74.
74. Nice way of thinking. So using what you know, and then you just had to mess with the 8, the rest of the 8. And you thought of 8 as 4 and 4. Nice thinking. Okay, so let's try another one. You ready? I'm going to move over here just a little bit. What about, you know what 53 plus 20 is? Put your thumb right here. 53 plus 20. What's 53 plus 20?
73.
73? Did anyone get something different? How'd you get 73?
I got 70.
Okay. And then you just added 3. So again, you thought about that 53 as 50 and 3. And so you know the 50 and 20 is 70, and you just have this 3 more, which is 73. Nice thinking. Did anyone use a number line and just left the 53? So they knew to start, they started at 53.
So I started at 53 and I added 20 more.
So you just know that 53 and 20 is 73? How do you know that?
So, well, like, I was just focusing on the 50 in the front, and I added 10, and then I added 20, and that would equal 70, and then all I had was the 3 left, and so I just added.
That's the great thing about adding 10 to a number, right? Like I can just think about those 10s, and then I know that this is going to stay the same when I do that, which is awesome. Great way of thinking about that, okay? Okay, so here's our next one. Y'all ready? Put your thumb here when you know. What is 53 plus 29? I wonder if you could use that problem before to help you with this one. I wonder if that problem before. So if you can get 53 plus 29, when you know the answer, put your thumb right here. I wonder if you can use that problem before to help you. 82. Did anyone get something different? Everybody got 82? Can you tell us what you did?
50 plus 20 equals 70. So then, and 3 plus 9 equals 12. And so I add that 10 to 70, so I get 80. And then there's only two numbers left. So then I add, so 80 plus 2 equals 80.
Ah, nice. So you like to split those numbers. So very similar to over here when we split both of the add-ins in both and you put those together. Nice job. Did anyone in here use the previous problem to help you do 53 plus 29? Did anyone did you use the previous problem?
Yes.
Okay.
So,
Okay, I'm going to can I have her explain too, okay? And then if you did it differently, we'll hear your way, okay? So tell us, how did you do it?
So, I used like the number line.
Okay.
And I started with 53.
Okay, so you started with 53.
And then I added a 10.
Okay, and what did that do for you?
Then I got 63.
63.
And then
You added another 10, and what did that get you?
I got 73.
73.
And then I added 9.
How did you add 9 to 73?
So, I counted 7 first because.
Why did you use 7 first?
Because 7 plus 3 is 10.
So it gets you, that 7 gets you to where?
8.
80. And then how much more do I need to jump? 2 more. And that got you where? 82. So you keep one of these whole, and then you jump by your 10s. Nice way of thinking. Now, did you do something differently? So tell us what you did.
So, I took 73
Mhm.
from the last problem.
Right.
And then I know 9 plus, like anything.
Uh-huh.
That, like, say 10 plus 4 equals 14. I know 9 plus 4 would equal 13 because it always equals 1 less. So I did 9.
You used the previous problem. You knew 53 and 20 was 73.
Yeah, no, I took, and then
And then you only had how much left?
9.
Okay. And so instead of thinking about that as 9, you thought about it as what?
9 plus 3.
9 plus 3. Okay. And so how'd you do that?
So I thought 10 plus 3 would equal 13, and then if you take 1 away, it would equal 12. So if you add 12 to 73,
Mm-hmm.
it would equal 82.
If you add 12. So we've already got the 3. I think you were thinking about this 9 as 10. So what if I add 10 to this number?
That would be 73.
Right, if I add 10 to this number?
83.
83. But I don't need to add 10. I only need to add
9.
9. So then what do I have to
You
do?
can jump back.
I have to adjust 1, and that gets me where?
82.
82. Awesome. Okay, here's our last problem. What about 78 plus 39? I wonder if you can think about adding something friendly to 78. Is there something you could do? Okay, right here, when you know, right here. What can you do? What's 78 plus 39? Can you think about adding something friendly to them? So when you know the answer, put your thumb right here. What'd you get?
117.
117. Did anyone get something different? So we all got 117? Okay. So tell us what you did.
I know that 70 plus 3 equals 10, so 70 plus 30 equals 100.
Mm-hmm.
And then 8 plus 9 is 17. 100 plus 17 equals 117.
Ah, nice thinking. I like that thinking. So again, we're thinking about splitting those, both in those, into 70 and 8 and 30 and 9. And then you put those together. Nice way of thinking. Did anyone keep this one whole? So they didn't do anything to the 78 and they jumped by 10s. Did anyone keep 78 whole? Did you keep 78 whole? Okay, so what'd you do?
I just did 78 plus 40.
Okay, so I'm gonna model that on a number line, okay, so that everybody can kind of follow us. So we're at 78, and then you did what?
Plus 40.
Why would you do 40?
It's because 39 is closest to 40.
39 is closest to 40, so you did a big jump of 40, and can you do a big jump of 40 in your head?
Yeah.
And what does that get you to?
118.
118, and then what'd you do?
And then you have to jump back 1.
Why do I have to jump back 1?
It's because it's one number above the answer.
One number, it's 1 too many, right? And so there's the 117?
Yeah.
Can anyone repeat what he said? How did he think about 78 plus 39 as 117? Can anyone think about what he said? Can anyone repeat what he said? Or put that in your own words? Can you tell us? What did he do?
Instead of adding the 8 and the 9 together,
Uh-huh.
he just added the 40 because if you add the 9 and 8 together, it'll make it other 10. So if you make it other 10, you can just add to 30 and then it'll make you 40.
Make you 40. So you know that he knows something about 39 is close to 40, and so you could add the 10s. Does anyone want to add on to that or say that just a little differently for us? Can anyone say that just a little bit differently for us? what he did. Do you want to tell us? What was he thinking?
So he was kind of thinking that he was, instead of thinking of the 39 as 40, he was kind of thinking of the 78 as 79. Then he was adding 79 plus 39.
Okay, so let me ask you a question. Is that how you were thinking about it? Winston? Is that how you were thinking about it?
Yeah.
Did you hear will you say it one more time? What did you do?
He was thinking kind of, instead of 39, instead of the 39 being a 40.
He thought about 39 as a 40?
Instead of thinking of the 39 as a 40, he thought of the 78. He thought the 78 is a 79.
Winston, is that what you were thinking?
No.
Can you want to repeat what you said?
Yeah.
Okay.
Like, I was thinking like 78 plus 40, because like 39 is closest to 40.
So you didn't do anything with the 78.
Yeah.
You just left that alone. And you just made this a 40. And why did you do that, Winston?
It's because 39 is closest to 40.
And is 78 and 40, are those nice numbers to add together? Are those numbers like kind of easier maybe for you to add in your head?
Yeah.
Yeah. So that got you to 118. And then what'd you do?
I just like subtracted 1.
Because you added 1 too many. Yeah. So y'all have some really good strategies I can see. And I see this idea is that some of y'all are breaking apart all the numbers, but I wonder if you can start thinking about keeping one of these numbers together and then just adding that second add-in and working with that number. So y'all had some really good thinking. As you noticed at the beginning of the number string, I went over with the students what signal we would be using, which would allow me to know which students had an answer. I use that signal to make sure and provide enough wait time for the students to calculate their answer. One of the things I'm really looking for is that I'm looking at their eyes, I'm looking at their hand movements, because I can actually see them calculating. And once I know that they have that signal up, then I'm pretty good that I can go ahead and ask how many, and they provide their answers. As you saw in the video, when the students provide their answer, I always ask, did anyone else get another answer? And then you notice that I go ahead and write those answers. And when they provide me with a different answer, whether right or wrong, I go ahead and write those answers up there. What I usually do, and what you saw in the video, is whoever gives me the first answer, they are the first student who gets to talk about and explain their strategy. That could also be, though, that it could have been the wrong answer. And that is okay, because in most cases, and there were some times in some of the video that you may see, is that students will correct themselves. Turn and talk is very intentional in the moment. So if I see students who are not necessarily being able to all vocalize their strategy, then I use that strategy to give everyone an opportunity to be able to speak to each other about how they solve the problem. One of the things I try to do is lean in and listen to some of the students' thinking. This also gives me some insight on what they are doing and then where I might need to go in my next steps in the number string. There may be times when students during a number string continue to use a strategy that they are most comfortable with, even when the number string was written for a different strategy to happen. So one thing you want to consider is just asking them sometimes to use that previous problem to help them. Number strings are written typically with a helper problem and then another problem that would use the problem above. So a simple question that you could always ask is, can you use the previous problem to help you with this one? And that will help guide your students in order to be able to start nudging them to the strategy the number string card was written for. When doing a number string, it is important to remember that when you are drawing the models, that you want to be as proportional as possible. The reason you do this is that you want to emphasize the magnitude of the number. You want students, if you're hopping on a number line, to see the difference between a 10 and a 1. Another component of daily math fluency is a math talk. A math talk is different from a number string in that it is only one problem. It is a time for students to share multiple strategies to solve that problem. In the Math Talk book is where you will find a few different strategies that students might use. The idea behind this is that this is not an exhaustive list of strategies. However, it is 4 of the most efficient strategies. And in a math talk, that is one of the things we're nudging our students towards, is we're wanting them to start to choose strategies that are the most efficient. They've also been modeled for you using a variety of manipulatives that the students should have been exposed to throughout the number strings. At the bottom of the Math Talks book, you will find a teacher notes section along with some facilitating questions. In the teacher notes section, it helps us know exactly how to conduct a math talk. It tells us about writing the one problem as well as modeling the student thinking on the different types of manipulatives. On the right-hand side of the teacher notes section, there is a place that has facilitating questions for the teacher. These questions are there to help guide students to compare the different strategies. For example, one of the questions asks the students to revisit their strategy and think about if they would still use that strategy, or did they see a strategy that might be more efficient? And I'm going to do a math talk with you today, okay? So one of the things that I just want us to remember is all we're going to do in a math talk is we're going to work on one problem. And what I want you to do is when you know the answer, I want you to take your thumb and I want you to put it right here, okay? So when you have your answer, just take your thumb and put it right here. Are y'all good? Okay, so here is the problem we're going to work on today. 47 plus 38. So when you have the answer for 47 plus 38, put your hand right here. What I'm going to have you do is turn to the people around you, and I want you to tell them, what did you get for 47 plus 38 and how did you do it?
What is 40 plus 30 and 7 plus 8? Yes. So you said 30 plus 7.
Did y'all tell each other?
Still kind of like
How did you do it?
So I put 14 plus 13 together, which is 17. And then I got 15 with 7 plus 8. So then I put the 10 for at the 17. So in there, that's
Did y'all do something?
that's 18, and then I got 85.
Oh, okay, I know. I got
So then
then I added the 8 side.
I got
97?
I got confused.
Did you do something? What did you do?
I just did 44 plus 1 more and 2 more and 7. And I added 8 plus 7 and I said, so I have to take a 10 and add 5 more because that's how I got it.
That's how you got it. Okay. Okay, if y'all will finish the sentence you're on, So I heard a lot of you talking with each other and telling each other what you got, what your answer was, and how you solved it. And so I'm going to start right here, and you're going to give me the answer. What's 47 plus 38? What did you get? 85. Did anyone get something different? Something different. Yes. What'd you get? 65. So look, really close. We have this 5 in the ones place. Nice. Anyone get something different? Okay.
Can I explain how I
Well, you know what? I'm gonna start with her because she's the one who gave us the first answer, and then we're gonna listen to her way. And then if you have another way, I want to hear it too. Okay? So we'll go start with you. What'd you do?
I added 40 plus 30 equals 70.
Okay, so I'm gonna stop there. 30 and 8. Okay. So now what do I do? You said to add the 40 and the
30.
So I'm going to add the 40 and the 30, and that gets me what?
70.
70. Now what?
And then I did 8 plus 7 equals to 15, and then I took away the 10 from the 15 and added to the 70. Then I did 30 plus 10 equals 80, and then I did 80 plus 5 equals to 85.
Equals to 85. So I'm going to stop here. You had 70 plus 15, but you didn't stop there. You thought about 15 as 10 and 5, and so you knew 70 and 10 is
80.
And then 5 more is
85.
85. Nice way of thinking about that. Did someone think about 47 plus 38 a different way? How'd you think about it? Did you get 85?
Yes.
Okay, so how'd you think about it?
I used 47 and then I plus the 8 from 38
Uh-huh.
and then I made 55 and then
Okay, so I'm going to stop you there. I'm going to model your way on a number line so that everyone can kind of follow along what you're saying, okay? So what I hear you saying is you left 47 alone, right? And then you said, I'm going to add the 8 to 47. So did you just know that 47 and 8 was 55?
no,
How did you add the 8?
I got the 7 from the 47 and I knew 8 plus 7 equals 15
Uh-huh.
and I plus the 15 to 47.
And so you knew that was 55?
5.
Nice. Okay, now what?
And then I plus the 30 from the 38 and I got 35 and 85.
So 55 and 30 is 85? Nice way of thinking about that. So how are these things similar? Can anyone tell us how these two strategies are similar? Are they similar? Yes.
Kind of. Just the 47 is a little bit greater than the 38 because it's 110
More?
more, and then the on the 38 it has a higher one, a greater one,
Uh-huh.
place, but on the 47 it has a less
Of a 10. Yeah.
but it has a greater 10.
What the greater ones or the greater 10s here
Yeah,
if you're
the
looking.
greater 10's place here.
You are using some really good vocabulary there in comparing those. So here's what I want to ask. How is this strategy where they decompose each one of the numbers different or similar to this one? What do you notice? So will y'all turn and talk with each other?
No, so like we all have the same five. On 47, the 10 and the 1 is greater than the 30. And another 8.
Finish the sentence you're on. So how Are these how are these strategies similar or how are they different? Yeah, so he kept this one whole, right? He didn't break that one up. And he just broke up the 38 into 8 and 30, which is what she did as well, right? But she broke up this number too. So they're similar in ways because they did it in a way that made sense to them. Let's talk about efficiency, because I already heard someone use that word. How many steps did this strategy take us?
A lot.
Quite a few steps. How much did Lewis take us?
That's only like a few steps.
Like 2 steps, right?
So basically, Lewis is more efficient.
It might be more efficient, but did they still get us to the same answer?
Yes.
Yes, they still got us to the same answer. So we're using strategies that make sense to us. Our goal is just to nudge just a little bit further. Let me ask, did anyone have a different way of doing it? So I want to make sure, yes, did you have another way?
Well, I turned it up to down, and then that made it a bit more easier.
So you put it up, so you turned the problem up and down?
Yeah.
Like this?
Yeah.
Okay, and so how did that make it easier for you?
And then I added the 8
Mm-hmm.
to the 7,
Mm-hmm.
and that made 15.
Okay.
So then I put a dot to the 4,
Mm-hmm. What's that dot represent?
a 10,
A 10.
and then I crossed out the 4 to
Okay.
make 5,
Because you put those together?
Yeah.
Okay, so you made a 5 now.
and then
5 tens.
50 plus 30 equals 8.
So that's 8 tens. Yeah. So that's a nice way of thinking about it too, right? Okay. During the math talk, you will notice that I used a signal to help the students tell me when they had their answer. Again, there was wait time given to allow all the students a time to be able to figure out the answer. One thing I do in a math talk at the very beginning is I go ahead and let them do a turn and talk with each other. This gives me an opportunity to really lean in and start to hear the different ways the students are thinking about it. The great thing about a math talk is this gives the students an opportunity to tell me the way that they see the numbers in the problem and what strategies make most sense to them. So after I have a variety of strategies on the board, you may have noticed that I had the kids compare the strategies. This gives them an opportunity to see how they are the same and how they may be different from one another. It also provides an opportunity for them to look at that one may have taken a lot of steps and took a lot of work to get to the same answer as someone who may have taken 2 to 3 steps. This helps our students see how some strategies are more efficient than others. Another great thing about a math talk is it provides an opportunity for teachers to help students make connections between strategies. In second grade, the strategies are sectioned off into 2 categories. We have our basic fact strategies, which are found on the first 2 posters. We have counting on and counting back, which are for those facts that are our +1s and +2s. All other facts should have additive strategies, which are located on this poster that talk about using 5, using 10, using doubles, get to 10, use 10 and adjust, and using known facts. You will notice that there's not ones that just say these are for addition or these are for subtraction. They are actually all used for both addition and subtraction. The last poster over here talks about strategies that are used in multi-digit. The same thing happens over here, that we have strategies that were written for addition as well as subtraction. If you are not familiar with the strategies, you can find each one of these in the teacher guide. In the back, you will find a list of each one of the strategies with an explanation. There's also a sample of how to model each strategy using one of the manipulatives. In each daily Math Fluency kit, there are 120 number string cards. The number string cards are arranged by strategy. In the front of each pack, you will find a table of contents that lists the strategies for each of the cards. What you will find is that each grade level is unique in the fact that the amount of cards for each strategy differs. In second grade, something you will notice is that there are basic fact number string cards, but there are very few of those. The reason is that in first grade, that is the main focus, is to help those students really construct those strategies. In second grade, our focus is more on building that automaticity. So the basic fact number string cards have been provided as a way for you to review what has previously been learned in first grade. What you will notice in second grade, it is very heavy on multi-digit addition and subtraction, because this is something that we focus on throughout the entire school year. In Daily Math Fluency, you will notice that the number string cards are in a particular order based on the strategy. This was done based on how students see relationships. In some grade levels, they begin with counting strategies because we know that students first start with counting. Then the strategies move to additive. This first starts out with basic fact strategies that are additive and then move into multi-digit addition and subtraction strategies. After students have started to construct some of these additive strategies, we then move into multiplicative strategies. Again, starting with those basic facts. Then that leads towards the idea of multiplicative strategies for multi-digit multiplication and division. So you may be asking yourself, how do I know what number strings to choose for my students? Here are a few things to remember. First, you want to think about where you are in your scope and sequence. For example, if you are beginning to work on reviewing basic facts, then this would be a great opportunity to pull out your basic fact number string cards, whether that's addition or multiplication. Another thing to think about is what strategies have your students already constructed. This is a good time to be able to move your students into more efficient strategy. And the last thing to think about is, since this is only a 10 to 15 minute routine, this is usually done as a way to continue to help students construct strategies after formal instruction has taken place. Earlier, we discussed that the number string cards were put in a certain order. I do want you to know that they are not intended for you to go from 1 to 120. It really is for you to think about where your students are. For example, in some strategies, there could be up to 10 to 20 cards per strategy. It would not be intended for you to do all 10 or all 20 cards for that strategy at that time. What I would suggest is that when you start to see your students construct that strategy, go ahead, move on to a new strategy, and then go back and revisit the cards that you did not complete at a later time. This will give your kids an opportunity to come back and review some of the strategies that they may have constructed earlier, but may have gotten out of the habit of using them. In Daily Math Fluency, the use of manipulatives and models was intentional. For example, we use the Reckon Rec in the lower grades in K2. When we use the Reckon Rec as a visual model, here is an example of what it might look like in the classroom. So if I put 8 on top and 7 on bottom and ask the kids how many they see, they may say, I know that's 15 because I see 7 and 7 is 14 and 1 more is 15. The idea is that eventually they start to use this model as a visual model in their heads for their thinking. So at the beginning, it becomes a model of their thinking while the teacher is modeling what they're saying, and then it becomes a model for their thinking. So when this isn't sitting in front of them, they still have that visual model in their head. The same thing goes with the flex-table grid arrays. So if you look at these, you can see that a student can say, oh, I see a 10 by 6. I know that is 60. And then the next one sitting beside it now is a 9 by 6. I know that that's 54 because it's one less group of 6. So the model is starting to help construct those strategies that we're trying to get them to start to see. And eventually, those models will become tools for their thinking.